So today we will learn torque acting on a dipole, electric dipole, with dipole moment P when it is placed in an external uniform electric field. Electric field is uniform, and you have your dipole with charges minus Q plus Q, and there you have electric field. So a force will be acting, and these forces on minus Q charge, on plus Q charge are in opposite direction, and they will constitute some torque. So today we will be learning torque on a dipole when it is placed in an uniform electric field. So let us see how it can be realized. So you have a dipole. Okay, so here in diagram, see the diagram. Electric field is along one direction. It is along in positive x-axis, and a dipole is placed at some angle with electric field. Let the angle is your angle is theta only. Okay, so this is the angle it is making. Here you have theta angle. Okay, theta angle. Dipole is making angle theta with electric field. Now we know that. And yes, one more thing. Your length of the dipole is 2L. If you initiate with your origin, here you have origin at the center. Let me take it as O, origin. So length will be equally divided into L and L. L plus L is equal to 2L. Now we have to find torque. So firstly we will be finding force on these two charges. On positive charge, force will be along the direction of electric field, and here you have force plus QE in the direction of electric field. And similarly, you will have some force. Okay, you will have some force on negative charge too, and that will be equal to minus QE. Okay, along another direction, in this direction only. Here you have force along this direction. Now, the two forces, force due to plus Q charge and force on plus Q charge, and force on minus Q charge. The two charges are equal, you can see, and is acting along opposite directions. So net force on the dipole is equal to plus QE minus QE, and it equals 0. So net zero force is acting on the dipole. Therefore, since force net is equal to 0, therefore no acceleration, means translation along one direction. One direction when at rest, when initially when at rest. Okay, Now next question, is there some torque acting? So let me realize that thing. So when I'll be finding, you know that torque is equal to R cross F. So let me find R and let me find F. Okay. So here you have now if you realize the torque which is acting on these two charges, negative charge and positive charge, by square rule. So you know that torque is equal to R cross F. So take the direction of R means length at one point. Here you have outward look on diagram. Okay. Here you have R vector along this direction and force vector is along this direction and angle is theta. So if you put a screw at this very point, at the joining of the 2 point, and if you tie this screw or screw this from R to F, you just bend it from R to F, the screw, you will find that it is tightening, it is going inward. So here the torque at the meeting point of the 2 is towards inward direction. On the other side, if you come along minus Q charge, the length vector is along this direction and force vector is along this direction, angle is theta. Again, when you place a screw at the joining of the 2 and you just screw or tight your screw, and when you screw from R vector, because R is your first vector, from R to F, you will see that again it is going inside only. So both the torques are along the same direction. So net torque will be the sum of the 2 torques. So torque will be added in both the cases, since the force are in opposite direction, and this force will constitute a couple, because if you assume that it is fixed at center, then the 2 force will try to rotate this dipole and the 2 torque will be adding to each other. So let me find the torque. Now torque is also equal to force into perpendicular distance between the 2 force. So it is equal to magnitude of force here. So let me find first of all what is perpendicular distance in between the 2 points. In between the 2 points, let me find the perpendicular distance. So this is your this is your perpendicular distance. This you have to find. This distance you have to find. So here D is equal to and you can get it with the help of, here you can see that angle is theta only, this angle, vertically opposite angle, this angle is theta only. In diagram you can see. So here let me write sine theta. Where sine theta is equal to perpendicular D upon hypotenuse 2L. Therefore, in place of D we can write 2L sine theta, and therefore torque tau is equal to, so here torque tau is equal to, let me put the value of all things, force is equal to QE, okay, into 2L sine theta, and this is equal to Q, here you have Q into 2L, that is equal to P. So let me delete this first of all. Okay, Q into 2L is equal to P. So P into E into sine theta, and therefore torque comes equal to P cross E. Now one more thing, if you change the origin, suppose here you have a dipole, and if you do not take origin at the center itself, you are taking origin somewhere else, then also torque will not change when dipole is placed in uniform electric field. Then your torque will not change by the change of origin. Let us examine this fact. So let us take one dipole in uniform electric field, and you have a dipole here, and the length of which is 2L, and suppose you are taking origin somewhere else, a distance x away from origin. Here this distance is x, and here you are taking the center and you are applying force. So on minus q charge, force will be along this direction, and on plus q charge, here you have plus q charge, so force will be along the direction of electric field only. Okay, so let me find torque along this axis of rotation that I have chosen. So, and you know that torque is equal to, and the two torques will be added. Okay, let me delete. Two torque will be added as they are acting along downward direction. acting along in the page, inside the page, along same direction. So we will be finding torque along this axis. Here this axis is O dash. This axis, your axis is O dash. Okay. In this diagram. So let us find the two torques along this axis O dash. So therefore, torque 1 will be force into perpendicular distance into D1. This distance is your D1. Okay. And this is equal to QE into, and this D1, this angle is same theta, so D1, here you can find D1 sine theta is equal to perpendicular D1 by hypotenuse. Here hypotenuse is changed, L plus X. This complete length is L plus X, okay. So in place of D1, you will be writing L plus X sine theta. And similarly, torque 2 on the other side will be force on plus Q charge into D2, and this is your perpendicular distance from the axis of rotation and the direction of force. This is your D2. So, and here D2, here also sine theta is equal to perpendicular D2 upon base. Base is your upon hypotenuse, okay. Perpendicular upon hypotenuse, and this hypotenuse, here you have axis of rotation and here you have a right angle triangle. So perpendicular is D2 and here sine theta will be D2 upon L minus, okay. This is your only, okay, L minus X. Therefore, torque 2 is equal to QE L minus X sine theta. So, when you add A and this B for torque net, so torque net is equal to, on adding, this is your 2 Q L E sine theta, and therefore torque net is equal to this 2E, this your 2QL, this is your dipole moment. So dipole moment, okay, dipole moment P into E sine theta, therefore torque net, again you obtain P cross E. So when you place any dipole in uniform electric field, then origin is not very important. You can take origin at any place and your torque will not be affected. Now question is, when you place the dipole in non-uniform electric field, this is second case B, okay, B. When the dipole is placed in non-uniform electric field, then you get that here your electric field is not uniform. Electric field is increasing in some direction. Here electric field is increasing along its direction. Okay, so what will you find? So here at this point, at positive charge, you have stronger electric field. Here E1 will be greater. As electric field is increasing, so E1 will be greater than here if you have E2. So here E1 is greater than E2. Therefore, F1 will be greater than F2. Okay. So force net is not cancelled to 0. Therefore, F1 minus F2 is greater than 0. So when you place a dipole in non-uniform electric field, then you will have both net force and net torque also. In this case, we find that we have force net, find force net and torque net. So matter is little bit complicated. So let us take two situations when torque becomes 0 and we have only net force. So when the torque will be 0, so we know that torque is equal to P sine theta. Now when theta is equal to 0 or theta is equal to 180 degree, then torque is equal to 0. So let us examine the two cases. When theta is equal to 0, when dipole moment and electric field are in along same direction. Let us examine. So this is your increasing field, and you have placed a dipole along the direction of electric field with dipole moment in this very direction only. So here you have a negative charge and here you have a positive charge. So what will happen? It will be experiencing greater force. Here if it is experiencing F1 and if it is experiencing F2, then F2 will be, okay, force on negative charge is along the direction opposite to electric field. If you have electric field along this direction, then force on minus Q charge will be along opposite to electric field, and force on positive charge is in the same direction, and the two forces are different. This force is greater and this force is smaller. So what we see, when dipole moment and electric field are along the same direction, the net force, here you can find net force net. So when you subtract bigger vector from a smaller vector, then you get a vector in the direction of bigger one. So net force is in the direction of electric field only. So what we find? We find that when the dipole is along the direction of increasing field, then net force will also be in the direction of increasing field. Okay, so Let us explain this with the help of an example. Suppose you have a comb and it is negatively charged, negative charges. And here you have base of paper. So under the influence of this negative charge, these negative charges, okay, let me draw a bigger diagram of dipole. Here you have a bead of paper. So under the influence of these negative charges, the light charges will be repelled. Negative charge will be repelled and positive charge will be attracted. Now you can see that field is along this direction and field is increasing. So on positive charge you have greater force, and obviously force is inversely proportional to square of R. R is smaller, therefore F1 will be, R is smaller, and here if you have F2, here you have R2 larger. F2 is inversely proportional to R2 square. Therefore, obviously, denominator is small, force is large. Therefore, force 1 is greater than force 2 along the increasing electric field, along the increasing electric field. Therefore, you have force net. So you have a force net in the direction of the charged comb. Force net, okay. And here I should write on the bits of paper along the charged comb. Now, in the same way, you can show that if dipole is case 2, dipole is in a direction, in opposite direction of increasing electric field, then the net force similarly will be opposite to the direction of increasing electric field.